In the previous video, we talked about derivatives. This video will talk about integrals. So what exactly is an integral? Well, it's pretty much the opposite of a derivative. When we took the derivative of a function f of x to get a function g of x, well, what is that function g of x? It defines the slope of the function f of x. Well, what's the integral then? The integral is pretty much the opposite. Let's say we have a function f of x and we take its integral to get a function e of x. So we have f of x and we take its integral to get e of x. Well, if we take the derivative of this function e of x, we'll get back to our function f of x. So that's actually the fundamental theorem of calculus, which is extremely important. The derivative of the integral of a function f of x is the original function f of x. Now, that probably clears up the definition of integral a bit. We go from f of x to e of x by taking the integral, and we go from e of x back to f of x by taking the derivative. Pretty simple, isn't it? Let's look at two examples of an integral. We got this function f of x is equal to 0.5. Well, what's the integral of this function f of x? Well, it's actually any line with slope 0.5. So 0.5x plus 3, 0.5x plus 1, so on and so forth. They're all actually integrals of just 0.5. Why is that? Because if I take the derivative of any one of these lines, what do I get? 0.5. And that satisfies the fundamental theorem of calculus. Let's look at this function, slightly more complicated. I got this function f of x is equal to 2x. Well, what is the integral of this function? It's actually any function which is x squared plus any real number. That's a constant c. Why is that the case? Well, it's because if I have any function x squared plus whatever, like x squared plus 1, x squared minus 1, so on and so forth, and I take their derivative, that means I draw tangent lines like I did in the last video, I see that the slopes are actually the same for this function, and so on and so forth. So you can see whether I vertically shift my x squared or not, however much I vertically shift it by, it doesn't actually affect its derivative. So I got 2x, I take its integral to get x squared plus c, and I take its derivative to get back to 2x. Pretty simple, isn't it? Now, in future videos, we will actually be using the integral to find the area underneath a curve. We need to use this thing called a definite integral for that, and we will be covering that in a future video. But so far, just remember, we got a function, we use its integral to go up one level, then we take its derivative to get back to that function. That's the fundamental theorem of calculus, extremely important. Now, I just want to clarify that the fundamental theorem of calculus only works one way. So it's possible to go from a function, take its integral, and then take its derivative. That's fine to get back to the original function. But you cannot do it the other way around. So if I have a function f of x, and I take its derivative to get this g of x, then I take the integral of g of x, well, I'm not going to get back, I may not necessarily get back my original function f of x. So remember, the fundamental theorem of calculus works only one way.